Hi class, welcome back. We're going to learn about algebraic expression part 2 index law. Today we're going to learn why index law is important and to prove that it's true. So what is index law? Index laws are the rules for simplifying expression involving powers of the same base number. So it's all about powers of atau pangkat. Now, these are the laws. There are three important rules, and the other are just the additional that you should remember. First is the first index law about the multiplication of both powers of base number. Then we also have that what happen if a number which is already being power of is being power of by another number. And then we have the third one, which shows that what happened when you divide a number, the same number that have different form of power, or indices. Okay, now let's start to the first one. So by understanding this, you can do a shortcut in solving math problem. For example, first we have to know the vocabularies, This 5 to the power of 3 or 5 cubed, the 5 is a base number and 3 is a powers or what you call as indices. So these are the same word, same vocabulary but different word. And so we can say that base number is 5 and the index is 3. We can read it as 5 to the power of 3. Next we have y and n with the power of n. So we can also say that this is the base number is y and the index is n. Now let's understand the index law. The first index law is a to the power of m multiplied by a to the power of n equals to a to the power of m plus n. So when we have the same number that have different form of index, we can add them. Example is 3 to the power of 2 multiplied by 3 to the power of 5 equals to 3 to the power of 2 plus 5. Or we can say 3 to the power of 7. Is this true? Let's prove it. So 3 to the power of 2 can be written as 3 multiplied by 3 2 times. And 3 to the power of 5 can be written as 3 multiplied by 3 as much as 5 times. 1, 2, 3, 4, 5. And since this is multiplication, we also multiply that. So how many 3's we have? 1, 2, 3, 4, 5, 6, 7. So this is true. 3 to the power of 7. Next is goes with the same one. 5 to the power of 6 multiplied by 5 to the power of 4, we'll get 5 to the power of 6. 5 to the power of 6 plus 4, which is 5 to the power of 10. And so, if it's an algebra word, problems will get b to the power of 3 multiplied by b to the power of 8, which will become b to the power of 3 plus 8, which is b to the power of 11. And this first index law has been proven, and this will be done for any kind of problems you will have. So it makes you simpler and faster. Next is index law of the second one. What happens when you have a to the power of m inside the bracket, and then you also make this to the power of n. It means that you multiply the index law. This example, a to the power of 3, and then inside those are to the power of 2. So we'll get 4 to the power of 3 multiplied by 2, which is 4 to the power of 6. To prove this, we know that 4 to the power of 3 and then to the power of 2 means 4 to the power of 3 multiplied by 4 to the power of 3 also. And we know the first index law when you have the same number, but and then in these, when you multiply them, you add them. So 4 to the power of 3 plus 3 equals to 4 to the power of 6. So it's also true. Same with the example of this one. 12 to the power of 5, and then inside the bracket to the power of 4. So becomes 12 to the power of 5 multiplied by 4, which is 12 to the power of 20. And this goes also for any algebra, which is f to the power of 4, indices to the power of 3, which is f to the power of 4 multiplied by 3, which is f to the power of 12. So this second index law has been proven, yeah, and it's true. So you can go to the shortcut and do it directly to get the result of a question. And then we have the third one is when you divide a number, yeah, with the same number but have different index or different powers, yeah, it means you are subtracting them. The example is 3 to the power of 5 by 3 to the power of 2 equals to 3 to the power of 5 minus 2. It becomes 3 to the power of 3, with the proof that 3 to the power of 5 means you make 5 times per 3 to the power of 2 means you multiply 2 times. Yeah, and remember we can scratch this. 3 divided by 3 is 1, and 3 with another 3 is also 1. And since any multiplication with 1 is it will change nothing, so now we have 3 multiplied by 3 multiplied by 3, or 3 to the power of 3. Yeah, same goes with a to the power of 15 per a to the power of 9. And then we get g to the power of 7 to g to the power of 6. Yeah. Okay. Next is just examples what happen when you have powers that is negative. So a to the power of negative m would be equals to 1 per a to the power of m. The important one is that the form is in the form of positive, yeah. So sometimes the solution in algebra wants you to have a form of index that is positive. And these are the examples. Yeah, you change it. Yeah. And the fourth one, the fifth one is when you have a number and then it is to the power of 0, any number will become 1. Yeah, these are the examples. 5 to the power of 0 is 1, 12 to the power of 0 is 1, 35 to the power of 0 is 1, e to the power of 0 is 1. Yeah, so any number when it is being indexed in 0, it becomes 1. Then the last one is when you have form of fraction in your index or in your powers. So a to the power of 1 per n would also means a to the power of root the n root of a. Yeah. So if it's a form of powers in form of fraction, it becomes a form of root of those number. Yeah, these are the example. 16 to the power of half means that it's square root of 16. 125 to the power of 1/3, same thing as cube squared of 125, which is 5. Yeah.